Welcome. In this video, we're going to start the study of the methods of integration, and we're going to talk about the integration by substitution. Now, in most of the integrals we've been solving thus far, they're just very simple integrals, and you just apply the rules like straightforward. But there are some more complex integrals, because previously you've seen that, for example, if we have, let's say, integral of x squared dx, that was the nature of the exercise we're solving. This was giving you what you did is just add the power here 1, and then what you're going to have is x raised to 3, and then divide the same thing here by the same power. Because this is an indefinite integral, what you're going to do now is you're just going to put plus constant c. Fine, good. Now, but not always things are very easy or are so easy like this. So in those situations we have to use the integration by substitution. Let us see an example. Say for example we have the integration of 3x squared, we can say 3x squared, yes, 3x squared plus 1, all of this into 6x dx. This is raised to 5. Now look at this. You have here this expression here in which you want to find the derivative or the integration or the integral of it. Now we cannot apply the same procedure we did over here, because this is just, we have different members here. We have this, and all this raised to the power 5, and the 6 is outside. So this we could only apply to this because we only have one x, but here we have more than one x. So how do we come out of these situations? And to come out of these situations, we use the integration by substitution. Now, what is integration by substitution? We have to remember that integral has a relationship with derivative. Integration and derivation, they are opposite operations. So if your derivative is taken somewhere, if your derivative is taken somewhere, the integral is taking you back, but do not be able to guess exactly what was the value of the constant. So we're trying to use this relationship to sort out this kind of problems. Now, in this case over here, what we do in substitution, we have to try to replace this by something which is going to be easy for us to solve. And the method of Udu substitution basically consists on this. UDU. So we're trying to transform this into this. Now, if you see this is a given expression. This du is the derivative of that expression. See this. What we'll do in this case, if we're trying to simplify all of this, we try to see what is the relationship between all the things that are here. So we're trying to find what would be a given expression, and if the derivative of that expression is also here. And then making a quick analysis, we can see that if we take derivative of all that is here inside, we get this value that is outside. If you have this and make derivative of this, not integral, derivative of this, you're going to have what? To take the power, you put it down, you're going to have 6x plus 0, because the derivative of 1 is 0. So you're going to have 6x. So the derivative of this is this. Good. So what are we going to do in order for us to solve this? Something we found. That thing that we found was u, which is our 3x squared plus 1. Now, the derivative of this was giving us something else which we saw, which was outside. What is the thing? It's called du. So if this is u, the derivative of this is what? This is the power rule. We're going to have here 6x, because this is in respect to x. See, this side is in respect to u, this side is in respect to x. Because this is in respect to x, we're going to have here dx. So this can be replaced by du, and this can be replaced by u. So what you're going to get, if you bring it here, we're going to have this. Now instead of putting all of this, what you can put is to replace it by u. You're going to have here u. It's raised to 5. See, that 5 doesn't affect anything. And then here we have 6x dx. 6x dx is du. So this is going to become here du. Fine. And now that we have this, it's easy to solve this. Why? Because this is one of the situations in which we have a power rule of integration. So what we're going to do, we're going to have this is equal to u raised to 5 plus 1 divided by 5 plus 1, which is one of the rules of integration that we have. And because this is an indefinite integral, we are going to put here a constant c. And then as a result, what you're going to have is u raised to 6 divided by 6 plus c. Fine. But we know that in this original problem, it's not with regard to u. It's not considering u as a variable. It's considering x as a variable. So we have to replace with the equivalent expression. Wherever we have u, replace by the value of u and du with the corresponding value. So in this case, we don't have du because we have now found the result. So instead of writing here u, we are going to write 3x squared plus 1. We are replacing in the place of u with the value of u here, and then we're going to put here 6 divided by 6, that is here, plus c, and this is the result we have. So we managed to find out the result of this expression here by using the substitution u du, because we saw that the derivative of this was this. So we could replace this with u, and its derivative here became du. So this is our u, and this became our du.